we're going to discuss angle measure and trigonometry functions. So learning objectives are understand the angle measure as a quantity. As we learned earlier, quantity is an attribute or process we can quantify or measure. An angle is a quantity. Understand two different ways we measure angles, such as radian and degrees. And understand the process of sine, cosine, tangent as functions. And be able to construct a unit circle. And we'll also see another functions related to sine, cosine, and tangent. So first, let's review what quantity is. A quantity is any attribute or an object or a process that can be quantified. That means we can measure. So when we identify a quantity, there are always these three questions. So here, when we think about angle, we have to think of what is the quantity of the angle and what unit of measure will be used to quantify it. So these two main questions are very common for us to consider when we think of a quantity. So angle is a quantity that measures openness between two rays. So let's look at definition of an angle. Angle is a union of two rays having a common endpoint. So here's an example. A ray is an unending directed segment. So it will go forever, like this direction. Same thing here, we can imagine go forever this direction. And they share a common endpoint called vertex. So this is the definition of an angle in geometry sense. Now our goal is to measure this. So angle measure. So like I said, an angle measure is a quantity that measures openness between two angles, two rays. So we measure openness between these two rays right here, or these two segments. So angle is a quantity, and it can be fixed quantity or varying quantity. But it is important for us to comprehend as a varying quantity so we can relate to a function. So there are two different unit of measure for angles. One is called radian, one is called degree. So unit of measure, like for example, when we measure a length, we can use inches, centimeters, meters, miles. For angles, we use unit measure radian or degrees. So let's investigate how radian works. So we really want to understand how radian works so we can really understand how varying quantity of angle can place in a function, trigonometry function. So let's look at definition of radian first. So radian is a unit of angle measure where 1 radian corresponds to an angle that cuts off an arc length equal to the radius of the corresponding circle, center at the vertex of the angle, or 1 over 2 pi of a circle's circumference. So what does that mean? Okay. So let's look at a picture. Well, equivalently, 1 radian corresponds to a rotation from the initial side to terminal side of 1 2 pi of a complete rotation. So two ways we can think about it. So let's just look at this picture. So 1 radian means that the arc length, this arc length created by this angle, if this arc length is same as this radius length, then we have an angle measure of 1 radian. Okay. And as you can see, this smaller circle, again, this arc length right here, if this arc length is same as radius length, whatever the radius length is, then we have the angle measure of 1 radian. So that's the basic idea of radian. And where does this 2 pi come from? We need 2 pi times the radius length to cover entire arc of a circle. So for example, if radius is 5 centimeter, then we need 5 centimeter times 2 pi to cover entire circle's length, arc length. So 1 over 2 pi means this length right here, 1 radian. 1 radian angle right here is 1 over 2 pi of a complete rotation. So let's look at a video next page just to demonstrate how radian works. So here, let me go back really quick. So in this example of this circle, we have a radius length of 2.5. Now, in order to construct 1 radian, we use that 1 radius length. So this arc length now is 2.5, and radius length is also 2.5. So then we have an angle of 1 radian. So that's what it means to have an angle measure of 1 radian. As you can see, 2 radian will go more this way, 3, 4. I'll demonstrate on the next page. So when we think of radian as an angle measure, we're using radius length as a unit measure to measure the arc length that's created by the angle. So on the next page, another video. Let me pause it real quick. So here we're going to look at several things going on right now. So we're going to look at the radius length is given as 4. Okay. And here at this point, again, the angle can be a varying quantity. It's not always a fixed quantity, it's a varying quantity. So as I increase the angle, you can see the arc length is increasing. So at this moment arc length is 3.92. Then we have 0.98 radian. That means that I need 0.98 of a radius length, 1 radius length, to cover this arc length. So let me keep playing the video to see where it goes. So when I have exactly, okay, let me stop right here. So let's say, just to round, I have a 4 arc length right here. When I have 4 arc length, which is same length as the radius length, then I have 1 radian. So do you see the relation between these 3 quantities? So angle measure also can be seen as ratio between the arc length and the radius length. So if I do 4 divided by 4, it gives me 1 radian. So let's see when we increase the angle. So here's about 1 radian. Okay. Then if I go there, there'll be 2 radian because I will need 2 radius length. Then I'm going to go to 3 radian. Okay, so let me pause it right here. So the 3 radian means that for this arc length, pretend that's arc. This arc length right here is 3 times as large as radius length. So as you can see, 4 times 3 gives me 12, the arc length. So one way to think about it is we're using the radius length as a unit measure. How many radius length do I need? I need 3 of them to cover entire arc length. So I have 3 radian. Of course, it's not always going to be nice even numbers. And a lot of times we have a pi also. So there's 3 radian. Then I increase, now I have 3.14. This is a pi. We're estimating to pi. So 4 times pi will give me about 12.55. So this angle right here is pi radian. Then I'm going to increase it more. Again, angle is a varying quantity. We increase angle. Now I have 4 radian, 6 radian, then 6 radian right there. Then if I go complete rotation, oops, we missed it. Here is 6.28 is about 2 pi. So this is 2 pi. We need 2 pi times as large as the radius length to cover the entire arc length of a circle. I also posted the GeoGebra tool link so you can play around with this on your own. So please check out the Canvas page. So basically, one way to think about it is we can measure angles in radian by counting how many radius lengths we need to obtain the created arc length. So angle measured in radian is arc length divided by radius length. Again, rather than just memorizing this formula, think about what this division means. Dividing means we're seeing how many radius can go into arc length. So let's look at some examples. 2 radians means, which is about 6.28. Then circumference of a circle is 2 pi. That means the circumference of circle is about 6.28 times as large as circle's radius length. Whatever the length of circle's radius, the circumference is always 6.28 times as large as circle's radius length. 2 radian, it means that arc length subtended by the angle is 2 times as large as a circle's radius. So you see the pattern here. Half a radian, 1/2 radians mean that arc length subtended by the angle is half times as large as circle's radius. So this is how we view and understand the angle in radian measure. And again, important thing is that angle can be varying quantity. It changes as we move along the arc length. If we think as a point moving along in the circle, an arc, it's a change in quantity. So let's look at an example. If an arc length is 15 feet and the radius is 7 feet, what is a measure of angle in radius? So here we're thinking relationship between those two. So we need to find out how many radius length is needed to obtain the arc length. So basically we need to see how many radius lengths, how many times 7 feet can go into 15 feet. And that's 15 feet over 7 feet. That's 2.5 radian. Second example. If the angle theta equals 1.3 radian and radius is 3 inches, what is the arc length? So 1.3 radian means that our arc length created by the angle is 1.3 times as large as a circle's radius length. So arc length is 1.3 times as large as the radius length. So we multiply these two. So arc length is 3.9 inches. So the angle is a varying quantity, and using radian, we can think as we're increasing the radius length, and that creates an angle, right? And we measure that angle using radius length of a circle. So pause this video and submit your answer to this problem below in Canvas. You can find the M2 video problems on the Week 2 tab. And the question is, what is the measure of the angle below in radians? So what I suggest is on your own paper, draw a circle and try to measure the arc length created by this. So try to measure this arc length using radius length. So this is drawn to scale. So make sure pause the video and try this problem. Click your answer on Canvas and come back and continue to watch the video. Okay, so if you submit the answer, let's go to degrees. So you might be more familiar with degrees. So degree is a unit of angle measure in which 1 degree corresponds to cutting off 1/360th of a circle's circumference within angle's rays. Okay. Equivalently, 1 degree corresponds to a rotation from initial to the terminal side of 1/360 of complete rotation. So, in degrees, what we as a human decide to do is we're going to cut off the entire circle into equal 360 pieces or slices. And the one slice is 1 degree. And 1 degree represents 1/360th of a full rotation. So we decide to divide into 360 slices. Okay. So we have 90 degree means 90 over 360. So 90 degrees is 1/4 of a complete rotation. And 180 degree, that means we have 180 slices out of total 360 slices. So 1/2 of complete rotation, and 270 will be 3/4 of a complete rotation. So degrees is we're dividing entire circle into 3 equal 360 pieces. Okay, so we need to be able to be comfortable with both degrees and radian. We should not only rely on degrees to understand what radian is. Radian alone itself is a very important idea because it helps us quantify and view the angle as a varying quantity. So we also have a little convention in position of angles. So what we do is we draw an angle in x and y axis in Cartesian coordinate. Okay. So we have origin here. Then this is the initial side or initial ray. And again, we increase the arc length, which means the angle increases. And where angle ends, go terminal side. So this is called standard position, means that we start from right here. Initial is always here. We can go this way, or we can also go other direction for a negative angle. So standard position just means that we draw an x and y axis, just for a convention. And if we draw an angle counterclockwise rotation, it's considered positive. And clockwise, so if I go clockwise this way, let me show you this way. If I draw an angle start from this direction, maybe see if I can draw an arrow. If I draw this direction, then that is a negative angle. So coterminal angles. So coterminal means that angles share terminal. That's why coterminal. So two, or again, it can be more angles that have same initial and terminal sides are said to be coterminal. So let's look at here. We have 140 degrees. This is initial ray. And we rotate this much. And this is the terminal ray. Okay. But also, we can start from here and we rotate negative direction, negative 220 degree. 220, yeah. It ends here. So these two angles are coterminal because they start at same ray and end at same ray. So they're coterminal to each other. And you can also go same direction. Look at here. This angle right here is 3 pi over 4. The arc length ratio and the radius ratio is 3 pi over 4. But the other green one is we keep going this way, right? We rotate. So like we spin for a while, but still it ends the same terminal ray, if you can see. So these two angles are coterminal to each other. So this is very interesting property of angle as a quantity. Each angle has infinite number of coterminal angles. Okay, and we can find coterminal angles by adding or subtracting full rotation, full revolutions. So we can keep adding 360 degrees, or we can keep adding 2 pi's, or we can subtract those two as well. Subtract means we go negative. So here, we have 140 degree. If we subtract 360 degree, we get 220, negative 220 degree. So we got a coterminal degree. We can also add 360 or 720, any multiples of 360s. Then we get coterminal degree. Here as well, we can keep adding 2 pi. Then we get 19 pi over 4. Again, each angle has infinite number of coterminal angles because we can keep adding or subtracting 2 pi. So it's video problem 2. Pause the video, then submit your answer to problem below in Canvas. You can find in the same place as you did for video problem 1. Question is, which of the below angle measure is coterminal with pi over 2 radian? So pause the video, find the answer, submit on campus. And once you submit it, come back and we'll look at trigonometry functions. Okay, so let's look at sine functions. Okay. So sine function, y equals sine theta, relates the angle measure theta to the vertical height of the point above the horizontal diameter on a circle. Okay. Or measure in radius length. So we're measuring this actually vertical length in radius length. So let's look at this picture. So sine function, we insert this as an angle as an input. And sine theta, sine of the theta measures the vertical distance from the horizontal diameter to the terminal ray of that angle. So, for example, if our angle, let's say angle was here, ended here, then our terminal ray is right here, right? Then sine theta will measure this vertical distance from here to here. It's kind of hard to see. Yeah. Or let's do negative angle. If I go this direction, if this is angle theta, terminal theta is right here. Sorry, terminal ray is right here, right? Then sine theta will measure this vertical distance. So again, important thing is that angle is a varying quantity. Angle changes. It's not fixed. So let's look at in more details definition of sine function. So for an input of theta radian, again, the input is a varying angle measure. Sine theta represents the vertical distance measured in radii or radius length of point on the circle above the horizontal diameter. So when I say horizontal diameter, in a circle, there's horizontal diameter right here, right? In order to measure this distance in units of radius length, we need to find the ratio of vertical distance to the radius. Or if I use this diagram, b over r. Therefore, we can write sine theta equals b over r. So again, imagine this arc length. Here's horizontal diameter. And again, we need to be able to imagine in our head that this arc length is changing, either increasing or decreasing. So as this varies, this angle varies, this height also changes, right? So sine of that angle measures this length as unit of r. So how many r can go into b? And as you can see, most of the times r will be bigger length than length b. But still we're using r as a unit. So if I do b divided by r, we're using r as a unit measure. How many r can go into b? Yeah, and most of the times we'll get fraction. The maximum we can get is 1. But this measures the vertical distance from horizontal diameter. So remember, the angle in radian is arc length divided by radius. So r here means radius. So what's happening is the sine theta, sine of this angle, again, this same thing as theta, right? Right here. This is sine, this is theta. Angle in radian is arc length divided by radius length. So what sine does as a function is it inputs an angle measured in radian and it outputs b over r. But b over r, one way to look at it is this distance measured in radius length. And we'll look at a more example, another video in few minutes. So this is the idea of sine function. Okay, so it is important for it to comprehend this way because theta is varying quantity. This triangle is not fixed. It moves. The sine function means that we have varying angles, keep changing angles as an input. So what about cosine functions? Cosine functions is similar ideas, but it measures. So x here does not mean it's input. When we say x as an x coordinate in Cartesian coordinate, x comma y. So x equals cosine theta relates the angle measure theta to vertical height of the point from horizontal diameter. Okay, so let me see what I mean by that. Oh, so actually I mixed up this toward. Oops, sorry. So actually I meant to say horizontal height, point above the vertical diameter. So I mixed those two words. So I think this picture makes better sense. If you look at right here, cosine theta measures this distance from vertical diameter. Vertical diameter. From right here. Oh, let me do it again. So from vertical diameter, it measures horizontal distance, this distance, using radius length as a unit. So this is the definition of cosine function. So as you can see, this is why it's so important for us to understand angle measure in radian. So let's look at more detail. Cosine represents horizontal distance. Again, measure in radius length. 1 radius, 2 radius, okay, or half a radius of a point of the circle right of the vertical diameter. To determine this distance in radius length, we must divide the actual distance, a unit in this diagram, by the length of radius. Therefore, cosine theta is a over r. So let me draw again here. It measures, so here's the vertical diameter, and it measures this length. But if we just measure this length, it's just a, right? But we're using it r as a unit. So we do a divided by r. How many r can go into a? So compared to radius length, what is this length? Right? So we're finding the ratio. So similarly, theta is again same arc length over radius. So cosine of that angle, we input arc length over r, and we get a over r as an output. Again, please understand what this output represents. It represents the horizontal distance from the origin, from the vertex, or we can also think as the vertical diameter, okay, to the terminal ray. So, what is tangent function? And again, if you had trig before, you probably remember tangent is only sine over cosine. But tangent is not defined by sine over cosine. It is sine over cosine, but it has its own meaning. So tangent function relates the angle measure to the slope of the terminal ray as the angle measure varies. So if you look at this diagram, I have this theta angle measure. And this theta, this angle creates, again, terminal ray. And tangent, as an output, it provides the slope of this ray. That's the definition of tangent function. So as we know, slope is change in output over change in input, or in this case, in this picture, b over a. So tangent, it takes angle measure as input. Output is a slope that created by that angle. Slope of the terminal ray. Okay, so it is not just sine over cosine. It also happens to be sine over cosine. But tangent itself is defined as an angle and the slope of the terminal ray created by that angle. So, in this video, again, it is very important for us to think angle as a varying quantity. angle is not always a fixed quantity. Like if you spin something, right, or if you're on a Ferris wheel on an amusement park, as you ride a ride, the angle changes every second, right? Or if you spin something on your hand, like if I have a rope, and if I spin it, angle changes. Angle varies every second. But if I have like a ramp, the angle of the ramp is fixed, so that we have angle as a fixed quantity. So again, here important for us to really switch our thought process and understand angle as a varying quantity. And here I'm going to vary, in this video, I'm going to vary angle, so I'm going to increase the angle and also decrease, and see what happens of the sine and cosine value. So here I increase the angle, and as you can see, as I increase the angle in first quadrant in standard position, the sine value increases. This length increases. Increases. Then if I come here, the red length means sine of that angle, and sine of that angle measure is 1. Whereas cosine, which measures the horizontal distance from the vertical diameter, is 0. So cosine is 0 at this point. So let's increase the angle more. Second quadrant. Then we can see the sine value decreases, right? This length decreases, where cosine value, so the length increases, but actually we view this as a negative length. So cosine length is decreasing, but in terms of magnitude, it is increasing. But because this length is negative, it's decreasing also. So here we actually have cosine as a negative 1. So distance between these 2 points, the terminal ray and vertical diameter, is negative 1. And for sine, the height is 0. The distance from horizontal diameter to terminal ray is 0. Then in the third quadrant, as you can see now, if you can see, sine is decreasing. Also decreasing again. It was also decreasing here because it becomes negative number. And it will go to smaller negative, and here we have sine of negative 1. The distance between the vertex of the angle, if you can imagine this angle right here, and the sine, the distance between horizontal diameter and the sine, the distance between horizontal diameter and the terminal ray is negative 1, and cosine length is 0. And here both angles are increasing. Yep. Then we have cosine value at this angle is 1, and sine is 0. So as you can see that how as angle changes, sine and cosine value also changes. So angle is a varying quantity. Now we can also go negative direction. Now we have negative angle as input. Right, the pattern stays the same, but we're going clockwise as negative angle. So this is the definition of sine and cosine. I'm going to play one more time, and although it doesn't say tangent, we're going to try to think what's happening to tangent function. So tangent function measures slope. So if I play this, tangent function is slope. So look at this dotted line. As we go here, the slope is increasing. Slope is increasing. And when we go to here, slope is actually undefined because vertical line, we do not have a slope. Slope is undefined. Now slope is negative. So this dotted line, the slope is negative. You see the pattern now. Slope is 0. Slope is increasing, now positive. Slope is undefined again. And slope is going towards 0. Negative. Or negative slope, now 0. So angle is a varying quantity, and tangent function tells us the slope of the terminal ray created by that angle. So now pause this video, then submit your answer to a problem below in Canvas. Find sine theta using the diagram below. Okay. So again, try to think in terms of So sine is the distance between the horizontal diameter and the terminal ray. Okay? Terminal ray. Using radius length. So here radius length is 5. So submit this answer. So pause the video, submit, and come back. Okay, so now we're going to look at sine and cosine functions in unit circle. Unit circle means that we have a radius of 1. Okay, so that means when we find the distance, we divide by 1. So if you look at here, here's a terminal ray, initial ray. Now here, this length is 1, radius is 1, 1, 0. So sine theta represents this divided by 1, and cosine this divided by 1. Okay. So idea is same. We're still measuring this distance using radius as a unit. So we divide by radius length. But because radius is 1, we can just measure this distance directly. We don't actually have to divide in terms of calculation. But the idea is same. So unit circle has a center at 0, 0 and radius of 1. And again, this is the same picture as earlier at a first quadrant. So unit circle can tell us some sine, cosine values. It can organize some values in an efficient way. Okay. So before we look at that, let's look at some special angles. So there are some special angle that formed by an angle that creates a right triangle, that these triangles has certain ratio among 3 sides of a triangle. So the angles are pi over 6, pi over 4, pi over 3, which is 30, 45, 60 degree, right here. It always has this ratio. So whatever this length is, the diagonal length is always 2 times the smallest length, and this length is square root 3 times the smallest length. This ratio is always same if we have these 3 angles in a triangle. And this one is also called 45, 45. If I have 45 or pi over 4, pi over 4, the ratio is this length and this length is same. And this diagonal length is square root of 2 times one of these lengths, or they're same. So this ratio always stays the same. So that means using this, we can find sine and cosine value of these angles, pi over 3, pi over 4, pi over 6, conveniently. So again, we have sine theta, cosine theta. So let's look at it one by one. And when we have the angle at this moment is pi over 6. Okay. Because we know the ratio, whatever this length is, although this length is 1 in this case because unit circle. Unit circle. So if this length is 1, we know that because angle is pi over 6, this length we know it's half. And that's why we have half here by that special angle triangle. If this is half, this distance right here is square root of 3 times this smallest length, which is square 3 over 2 right here. But because sine and cosine measures these lengths, this is sine, this is cosine, we actually have sine over cosine. So sine of pi over 6 is right here, square 3 over 2. Oh, sorry. Cosine of pi over 6 is square 3 over 2. And sine of square pi over 6 is half. Okay, so actually this is typo. I need to switch this. Okay, so I'll try to fix that. So we actually have cosine comma sine. Okay, so let me go back to the previous page. Like here, this is correct one. So this is the unit circle, special angles unit circle. So again, this is just a tool for us to evaluate sine, cosine value at certain angles. So you need to be able to construct this, and I actually am going to post another video how you can draw this from the scratch. Okay. So you need to be able to reproduce this on a blank paper on your own. And I do suggest you do that. While you take the quiz, you have a blank paper and draw this first. So you can use this to evaluate sine, cosine, and tangent as well. Because tangent is slope, we just need to find change in y over changing x using this. At only these angles though. Okay. So now let's look at right triangle trigonometry. So this is an alternative way of thinking trigonometry function. Okay. So trig functions takes an angle measure as an input quantity and produce certain quantity, certain ratio quantity from right triangle as output quantity. So again, if you took trig before, you might have seen this. But again, this is not the most productive way to think about sine, cosine, tangent because this feels like angle is fixed here. It seems like we can only do sine, cosine, tangent when we're given a right triangle. Okay, but as we saw before, as angle increases, right triangle shape changes, right? And it is simpler to think about angle as a varying quantity than right triangle shape changing as a varying quantity. Okay, so yes, we can use this idea to evaluate certain sine, cosine, tangent as an output. But do remember that angle is a varying quantity. And other trig functions, we have cosecant. This is how we say cosecant here. This is cosecant, which is 1 over sine. We have secant, which is 1 over cosine t. Cotangent as 1 over tangent t. Okay, so they're reciprocal to each other. So we can find these values once we find sine, cosine, and tangent of the given angle measure.